Apropos of nothing, I'm back with this JavaScript game tutorial that I started a month or so ago. A long time. I left it going too long. But I'm back, and I'm going to finish it, if only for my own sake, for my own sanity. So, right now, all we have is this. We have our player ship, which we can tell it what angle it's pointed at, but we can't really move it yet. And we have this asteroid, which will automatically adjust. It'll jump when it hits the edge of the screen so that it scrolls forever. I'm not entirely sure this is how the original Asteroids worked, but this is how my version of Asteroids works. It makes things simpler because we don't have to keep generating new stuff if objects leave the scene or anything. If you haven't seen part 1, definitely pop over to my stream archive on YouTube and you can check it out there. I might have to, I feel like, hang on. I'm going to adjust something real quick because, I don't know. Maybe that's better? It seems like I'm peaking on the mic a little too much, more than I should be. That should be a little bit clearer, a little cleaner. So anyway, let's just get right into it. I don't have much else to do today, and it's pretty lousy outside. So here's my development space. I've got the PowerShell open because I'm working in Windows. And you don't need to use Python to do this tutorial. You could just load up. You could like open the HTML page in your browser like this. But I like to use Python because it just means that, I don't know, I think it's good practice. You can, if you want to get fancier, you can serve up stuff with the server and do weird. You can do more functionality with the server than just reading the file off of your computer. So yeah, I think the next step we want to do is we want to get our spaceship to move. So we have a bunch of functions on the asteroid currently, but our player ship can't move yet. I'm trying to refresh my memory here. Yeah, I guess the first step is let's just write out some functions that will let us move the player ship. So we have our ship object here that just holds x and y position, and theta is our current angle in radians. So that goes from 0 to 2 times pi. 2 times pi is a full rotation. So let's just write our function. I'm going to kind of go object-oriented here, and we're going to, even though I probably should make a ship class and instantiate it, so let's actually do that now. And we're going to call this, I'm using sort of older JavaScript syntax because in some cases that works better for event binding and stuff. And also it means it'll work in more browsers. It's more compatible. So let's call this function player. This is going to be our player ship, and then I have to rewrite these a little bit. We have to use this to declare member variables. Right? Luckily this, if we, having converted that, we should actually do this. So that instead of the ship being a standard JavaScript object with arbitrary properties, we've instantiated a class to our ship object, and this should all function the same way. Before we take any further actions, we should double check and make sure that it actually is working the same way. So I'm going to refresh the page, and everything looks fine. The scene is still going. The ship is at an angle that I think we set manually. just for testing purposes. That's right. I just set the ship angle to an arbitrary number of radians. So let's say we want it to point up. I'm going to say minus math pi, or not even. We'll do divided by -2. If we did, I could do minus math.pi divided by 2, but I think that ends up being 2 operations, whereas math.pi divided by -2 is only 1, so it's just slightly better. I think we also should instantiate the player in the middle of the screen, which is... which I think is how Asteroids works. So I'm going to change that to be... we're going to use our render context. I can auto-complete it. And we can get the canvas width and the canvas height from it. I hope my, I hope my mechanical keyboard isn't coming through. I got it recently and it's noticeably louder than my older keyboard, but it's very comfy to use. I think it's being caught. I think the noise reduction is eliminating it. All right, so I've changed things a little bit. We should be pointing math.pi divided by -2 should point us up, because I think the ship, our ship lines that define the shape are pointing to the right by default, which that's standard coordinate system. Yeah, so now we're pointed up and we're in the middle. Standard kind of coordinate systems are that 0 degrees of rotation means that from the center you're pointing to the right like this. So you have to go negative quarter turn to go up. Oh, oops, I forgot to switch back to the scene. Sorry. We're 0 degrees would be this, so we're pointing negative 1/4 turn to go up. Anyway, it's back here. Much like with the asteroid class, we can use the prototype thingammy. I don't know what it's called. Prototype. We can use prototyping, I'll say, to make some member functions. Like the first thing, let's say prototype turn, and then we'll have direction. That's right, it needs to be a function. And we're going to say, I think direction should be either, it should be +1 for turning right, which is increasing the theta, the degrees, and -1 should be turn left. There's probably a more, if we had more control over variable types, we could, we could save a little space by doing something like an integer, or we could do an enum, E-N-U-M, where we're just using unsigned integers or even Boolean or something. Actually, you know what I'm going to do? Okay, I'm going to say turn right, and that's going to be a Boolean. So we're going to say if turn right, we're going to do, turn, we're going to say increase theta. So I'm keeping this simple. We don't need, the way I say it, we don't need an integer number because the turning speed is always going to be the same. And we don't need a float, obviously, either, because we're not going to get so granular in the turning speed. So all we really need is a Boolean value. If we're calling the turn method at all, we're either turning right or turning left. So it can just be a Boolean. So what do we do to increase the theta? Well, let's say, let's first come up with a constant called ship turn speed. Oops. And I'm using, how the heck did I do that? There we go. I'm going to use all caps snake case to declare our constant, and let's see. I'm going to say the ship turn speed is 1 for now, because it's going to be 1 radian And it's going to be multiplied by the delta, which is the time in milliseconds since the previous frame was rendered. If you're running on like a 60 frame per second monitor, that's going to end up being about 16 milliseconds. So that means that every 16 that means that we're cutting down the time. If you're the easy way to think of delta in this kind of sort of frame like, let me back up. So the reason that we're going to multiply by delta, which is a variable I should include in here, the reason we're going to multiply by delta is because we want our ship to be moving and turning regardless of the actual frame rate of the monitor that is displaying the game, because they can be all over the place. Old games, really old games, it didn't matter. Sorry to adjust a little bit. In old games, it didn't matter because you had like a TV. If you're playing, you know, an NES on a TV, it would have like a constant output rate, or the device itself would output at like a constant frame rate, more or less, and you would have such granular control over it, it wouldn't matter. But modern computers, you need to be a little more flexible. I think I must have discussed that when talking about the Asteroid, but at any rate, I'm reiterating myself. The easy way to think of it is that any change that we make to an object's position or rotation or anything is going to be in whatever the relevant unit is. With the rotation, it's radians per second, because we multiply by delta, which is going to be, we're dividing delta by 1000 to get it from milliseconds into seconds. So our turn speed, I'm probably going to adjust this to something that feels nice, but for now it's going to be 1 radian per second, which is honestly is going to be probably too slow. So when we call the turn method, we're going to do, if we're turning right, we're going to say this theta plus equals delta times ship turn speed, which I'm going to autocomplete. And then we can do nearly the same thing for decrease theta and just do that. I'm also going to add an extra condition for each of these. If this theta is less than 0, then we add tau, which I think, did I declare tau earlier? Tau is a nice constant to have. Yeah, I did hear this. Tau is a nice constant to have in this instance, because tau is actually a full rotation in radians. It's basically pi times 2, excuse me. So actually, I'm gonna type that here too, and I'm gonna say tau divided by -4, just because that's a clearer indication of what the rotation actually is. We're saying it's a quarter of a full turn. Now here I'm adding this condition because, oh, I did this. This is the wrong one. Hang on. If theta is greater than tau, we're going to subtract it. Basically, I want to keep the ship's theta value within a range of 0 to tau. Yeah, if it's less than 0, it's not a big deal, but potentially you can run into floating point errors if somebody turns the ship enough times, where if the number gets so big that you start losing precision because of the way floating point numbers work. I'm thinking, I think if it's greater than or equal, because tau is a full rotation, so tau, if the theta equals the full number tau, then we should go back to 0. So greater than equals tau or less than 0. So now we have this function, but we need to actually attach it to something. What I'm going to do is I'm also going to add a process method for the player. So this turn is going to be called every frame, I think. But process is going to contain it, and we're going to... turn is only going to be called based on whether... I'll get to that in a bit. Process is like the one function that we're going to call, much like with the asteroid. This is going to be the one function we call every frame. I think... Oops. I need to mute my phone. Sorry about that. Right, so... What am I saying? Process, much like the asteroid method, we're going to have this one method called process that we're going to run every frame, which accepts our delta. And for now, I guess I'm just going to say this turn true delta. And then down here, after our test asteroid, we can do ship process delta. And we should see, when I go back to the browser, if I refresh the scene, we should see the ship turning right at a constant speed. So let's see. There it goes. Now that, like I thought, that's a little slow. But I think before we make adjustments, I'm going to actually attach user input so that we get a feel of what it actually feels like to be turning the ship. So, I guess because it's related to the ship, I may as well put this down here. So let's start writing some, or you know what, I'll put it after the ship. I'm going to put my user input down here after the ship related stuff. So let's make our function and actually call it something. Okay, so we're going to say handle user input, or no, that's not right. Handle key down. I'm having to refresh myself because I haven't done a JavaScript game in a while. So we're going to attach this. I'm actually going to put it right here. We're going to say document. We're going to add an event listener. Most web developers won't be used to this kind of syntax because we like to use jQuery. Oops, and I mistyped. We like to use jQuery, and this is our standard vanilla JavaScript way of doing things. So here in our handle key down callback, we're going to do just that. So let's say we're going to say if event, not repeat, because I think that is an accepted. I think that's a cross-browser now. You can check that the event is not a repeat, or it might be echo. I'll double check in a minute. So on handle key down, we're going to check what we're going to use a switch statement because it's nice and easy to do that. We're going to check which key it is. This can be a little bit of a problem if you really want to support like Internet Explorer and some older browsers, excuse me. You have to process key codes and stuff, which is a real pain in the neck. The event key property is just like a name of a key, luckily. So we can just say, if our event key, I'm going to go a step further actually, and I'm going to say to lowercase so that, or no, you know what? We're going to assume that you don't have the shift key or caps lock enabled. And I'm just going to implement some WASD controls. So let's say that D, I think we have to do case, yeah. Case D, now we got to figure out what, how we want this to actually connect to the player's ship. Because what we want to do is we want to turn the ship if the key is held down. You know what? Let's add a property to the player object. We're going to say this dot turn turning. Okay, I might have to step back on this turn right thing because I have two options here. I can have two booleans, one that says the ship is currently turning, and one that says it's turning right or not, meaning if it's not, it's turning left. Or we could just have a number that has 3 states. So I think I'm just going to do that, turn direction, and we're going to say that's 0. So I'm going to have to change this. but since it's turn direction is a property of player object, we actually don't need anything extra. We can just say this dot turn direction equals 1. I might even do a triple equals just to save, because it should already be an integer and we don't have to convert it. And then we can do the same here. Turn direction equals -1. We go left. So this is the more memory using. It's not too important. It technically, we're taking up more memory space by declaring an integer instead of a Boolean, but it's not that big of a deal. And in fact, it makes more sense for connecting our key down events to actually make the player turn one direction or another. So, as long as the turn direction is set one way or the other, the player will currently now turn in the appropriate direction. By default, it's 0. So what we want to do in our key down event is we want to change which direction the player is turning. So I think let's add another player method for that. When you're doing object-oriented programming, you generally want to ensure that your objects handle as much relevant to themselves as possible. So in this case, I could just say handle key down, case D. D is generally our right-facing thing, so we want to turn right. And turn right is, we've established turn right is going to be 1, a positive number. And our ship knows that. Our ship object, our player object knows that. And so we could just do it directly. We could directly manipulate our turn direction object, property. But I think it's better to have a method on the player because, for one thing, let's actually do it. This turn direction equals new direction. For one thing, this value should only ever be 1, 0, or -1, which means that if we set it directly from outside of the player object, that we could easily manipulate, we could easily give it the wrong value. So if we wanted to be really safe, we could, in this method, we could do some kind of checks to make sure that we're only assigning a valid value to our property. Also, we might want to do something else when we decide that the ship is going to start turning in a direction. Like if we wanted to add animations or something, like some kind of jets on the side that kind of poof it in one direction or another. This method would allow us to do that all inside one tightly contained method, in which case we don't have to change this code at all because it would still be saying ship dot set turn direction, right? And plus, we even don't need to know. A better way to do this even is we don't want we shouldn't need to know what the direction value needs to be. Like we shouldn't need to know outside of the player object. So I'm going to actually backstep again. This is all off the top of my dome. Like I haven't planned this very well, clearly. But I'm actually going to change this. I'm going to say start turning. And we're going to say, we're going to do the same. We're kind of going to do what we did before. So turn right is going to be a Boolean. And I'm going to get rid of this. I'm going to say turn right greater than turn right question mark. If turn right is true, then we want 1 because 1 is turning right. Otherwise, we want -1. So then down here, turning, in our start turning method, all we have to do is call true or false. True for right and false for left. So let's add a for left, and we're going to say true, false. And there we have it. When we press the D key, we're going to call set turning, which will tell the ship that on the next frame that we run process and by extension turn, that we want to be turning right. Otherwise, turn left. We can actually, with this, we can refactor this whole method actually. Because we don't need to do these if checks anymore. We can actually just do arithmetic. I forgot. This is a good reason to have a number value for something like a turning direction. Because instead of what we did before, instead of this, you'll notice I moved these outside of the if-else statements. It'll make sense in a second. Instead of these if-else statements, all we need to do is we do this dot theta plus equals delta times ship turn speed times this turn direction. So everything comes together in this one line. We can get rid of all this. Because now, if our turn direction is 1, we want to turn right, then we increase the ship theta by its turn speed, obviously multiplied by the processing delta. If it's -1, we want to turn left, and so we decrease the theta by the ship turning speed. And so, with just one simple line of arithmetic, we solve this problem. And of course, we do have to do both of these checks. Or rather, we don't have to do both, but we can do one and then the other. I'm going to do the 0 first because I like the consecutive nature of that, where we check 0 before larger numbers. I don't know. Personal preference. But we do have to check, after having done this, we do have to check each option. If theta is less than 0, we bump it up back in range. If it's greater than tau, we bump it back down into range. But here, with all this, we've kept things simple. We're not repeating ourselves too much, so to speak. And now we should have, I've added this keydown event to the document. And unless I've mistyped a property name of the event object, we should all be good to go to start getting some responsiveness from our player ship. So I'm going to restore the page. Nothing's moving yet. If I press D, we start turning the wrong way. Good to always test these things. If we press A, nothing happens. Great. But it did respond to a key press. So that's a good start. Now we got to go back and interrogate the code. So let's see. We have ship start turning. Oh, I know why. With switch cases, you got to have a break. And I forgot to include that. So basically what was happening, this is actually very instructive. So if you don't include a break in a switch case, the code will proceed to the next line, to the next case. In this event, I'm not sure why it was turning left, but I might have set this up incorrectly somehow. The point is that whether I press D or A, we end up executing the same function. So there, this is what we actually want. I've noticed that by default, Sublime Text likes to indent this way so that this kind of falls underneath, but I think that's harder to read and harder to separate your cases. So unless we're doing like a one-line switch case, individual cases, switch cases, I think this is easier to read, but it's just me. I might be wrong. At any rate, this is what we actually want. We need these breaks in our switch case statement. So let's go back to the browser. Back to the browser, going to refresh. We're not moving anymore. Press D, and we turn in the correct direction. I press A, and we stop and start turning in the other direction, which is great. It's very quick and responsive. It's still kind of slow, but we'll deal with that after we deal with the fact that the ship does not stop turning after you let go of the key. So that's our next step. We need to handle key up as well. I guess I'll make this lowercase up. I'm not sure. The event names, as you can see here, are always all lowercase, so I'm not sure if like key down, if it's like key space down or underscore down, like if the down is meant to be separate or not. So I'm just going to do handle key up as one word. Great. So again, we don't have to do event repeat on this one because key up events do not repeat ever. I will mention the reason that I put the not event repeat is just because we don't want to keep calling this method as long as the key is being held down. We only want to catch it the first time. you probably won't notice on most computers, but it can potentially, you're still eating up processing power by having to do the switch case and calling the method every, I don't know however often these key events happen, because they happen more often than a standard browser refresh rate, that's for sure. Mouse events are even worse. You got to be really careful with mouse move events. So on, I'm gonna set up our two cases. I'm gonna just put breaks in there to start so I don't forget again. But we need a new method. We need a new method for our player prototype. I'm just gonna duplicate this so I can save some typing. I'm gonna say stop turning. So our stop turning method doesn't need any arguments this time, but all we're gonna do is this turn direction equals 0. Nice and simple. So down here we can do ship stop turning for both. Now you may have noticed a problem here, and the problem is if we have both keys held down and we let go of one, then we'll stop turning. And we won't keep moving even though we're holding down the other direction key, which is a real problem. You may have noticed it because I noticed it as I was just typing this out. So this is the simplest thing that you could do. But I think the smart thing to do is we want to effectively, we don't want to call this method again so much, but we do want to probably have a more robust system for tracking our inputs. So I'm not going to change anything here, but I am going to go, before I proceed, I'm going to go back in the browser and we're going to check that this works as written. So I hold down D, I let go, and nothing happened. Oh, that's right. I didn't attach the event to anything. That's my bad. So let's duplicate this. We're going to say key up, and it'll key up. There we go. So we have both of our event listeners are registered on the document. And now if I refresh, I'm going to press D, I'm holding it down, letting it go, and it stops. Pressing A, holding it down, letting it go, and it stops. Now if I press both A and D together, let's say if I press D and then A, I'm holding A and D at the same time, but I'm turning left because I pressed A second. If I let go of D, I stop moving, but I'm still holding A. So by the logic of somebody playing this game, this doesn't really work right. If you're pressing both direction buttons, you shouldn't be turning at all. If you press one and release the other, or sorry, if you press both and you release one, whichever key is currently held down should be the one that determines what direction you move in. So you should still be moving. And in that case, I think we need a more robust system. So I'm going to actually make an object called key, I'm going to say just like input status. I could make another class here, but for now I'm just going to have this list of true and false objects. So we're going to say, so our input status is going to be turn left, false, turn right, false. And we're going to add to this as we progress, but for the moment, we're going to start changing some of these. So when we press the D key, we want to change our input status, turn right equals true. And then we want to do more or less the same for this. Turn left equals true. Crucially, I've named the input statuses to the function that I want the input to do rather than hard coding it to the key that we're inputting. I think that's important. You don't want to, if you want to get really involved in, hang on a second. There we go. If you want to get more involved and make a more robust game engine where you allow users to change their key bindings, then this is the way to do it. You want, internally, your system should be checking on what the command is rather than the exact key or, joystick or whatever input. So we're still technically hard coding this stuff because we have our event listener, listening for specific keys, but I'm not going to really get into key binding, like optional key binding stuff in this tutorial. It's a little too involved for such a simple project, especially since there are really good JavaScript game engines out there that would save you a lot of trouble. But for now, oh, you know what? I did this wrong. Dang it. Okay, so, no, that's not entirely true. I guess we could do this. This is a little more complicated than maybe it needs to be. But basically, with this input status, I think we don't need to have these functions anymore. I'm just, you know, making this stuff up as I go. But in the process function, I think what we want to do, okay, here's what we want to do. So for the ship, we want to have a new property. Let's say, because what I'm going to do is in the process function is I'm going to be checking our input status to determine when, to determine how to change our turn direction and later other inputs as we add them. But we don't want to check it every frames. We don't want to check it every frame that we call process. So I'm going to create a new property on the ship, which is, you know, handle input change, I guess. There we go. So handle input change. So what I'm going to do here, this is a little weird and maybe this isn't the best. Maybe this isn't the best way to do things, but I'm going to say that whenever we want the ship to be, we want to kind of queue up. No, we don't want this. We want ship. No, you know what? I'm not going to do that. Never mind. Forget all I was saying. I think every frame will just check for the current thing is, because I was thinking about it, and actually, this is still kind of a problem. There's a potential problem with this kind of, with browser development, where if you leave the browser and come back to it, the browser window, then the browser doesn't really keep track of which keys are pressed down and which are released. We've kind of done that here, but these events only trigger when the browser window is in focus. And so it's not the best way to, you know, browser game development is not great, obviously. Like, there are so many problems. But this is sort of the best we can do. I think for now we're just going to do, I'm totally backtracking. So forget I was saying anything about that input change stuff. Instead, every frame in the player object, we're going to check the status of our input actions. So we're going to say if, we're going to say if input status turn left, let's say turn right, and then if input status turn left, and I'm going to fill these in a second as I explain what I'm doing. So we're going to say new turn direction equals 0. Now this is how we solve that input problem that I was talking about. If our status is turn right, we add 1. If our status is turn left, we subtract 1. Now you may think, well, why don't we just change the member property directly? And I think it's better to create this new variable in the process function because it's local to the process function. It's quicker to look up in memory. Who knows whether it actually makes a significant difference, but suffice it to say, all we have to do now, I'm going to take a little extra step, and I'm going to say if turn direction doesn't equal the new one that we just made, then we assign it. So what we've done here is we start off with the assumption that the ship is not turning in either direction. If the user is pressing the turn right key, we give it velocity in the turn right direction. If they're pressing the turn left key, we give it velocity in the turn left direction. And so they cancel each other out if they're both pressed. And if only one is pressed, then only one direction is valid. And with our handling key up method, now we no longer cancel the ship's speed, turning speed entirely. We instead wait until the next frame and we actually check which keys are pressed, which actions are queued up, and from there we can from there we determine which way to turn. So having done all that and having rambled on and backtracked over a bunch of stuff I was saying, let's refresh the page again. Everything looks fine, nothing is moving. I'm going to press and hold D, we're moving like we did before. I'm going to release it and we stop. Great. Press and hold A, we're moving like we did before. Press and release it, we stop. I'm going to press D and I'm going to press A, and now look at that. Both of them down and we stop. And we're going to stay stopped until I release one. I'm going to release the D key and we start turning left, which is great. I can press it. If I release the A key, we're turning right, which is great, because I'm currently holding D, which is the turn right key. So everything works as you would expect it to. Holding both directions means that you don't move at all. Holding one or the other means you only turn that way, regardless of which key was released. It may seem like a minor feature, like a minor deal, that what we had before, where releasing either key would totally stop the ship from moving. But when you're actually playing a game like this and things can get kind of intense, you will definitely notice it. So now comes the time to sort of tune, or you know what, I want to tune the ship's turning speed, but I think it's better to get our ship moving first. And if I remember correctly in Asteroids, you can only move forward. So I'm going to add a case for the W key, W. And we're going to add a new input status. We're going to say input status thrust equals true. If I can spell correctly. Good grief. So we're going to add, oops. Boy, I'm just mistyping and like, I'm just a butterfingers today. Here we go. And we're going to set thrust to false in the key up. In the key up method. Great. So now here, we're going to have, what should we call the message? The function. I guess we can call it thrust. So this one's easy. No, it's not. So this gets a little complicated. We have to bring trigonometry back into the fold, like we did when defining the draw closed shape and draw line segments methods on the previous stream. So we have to go in here because we want to add velocity to our ship in the direction we're facing. And to do that, we need to have like an X velocity, Y velocity, like some kind of way of determining our direction. Probably the best way to do that is to, in our turn method, we can assign, or we can update the player object to maintain sort of a something like this, just y, or maybe even we can do sine and cosine. Because if we do, here's my thinking. We need sine and cosine to determine which way, actually, okay, so sine and cosine, we want to actually set those to what they are. So I'm going to say math sine, this theta, and math cosine, this theta. We want to initialize these two properties as relating to the current ship theta. So we kind of have two options here. We can either, every time the thrust method is called, we calculate sine and cosine of the ship's facing direction, or every time the turn method is called, we update sine and cosine of the ship's current theta, which we then reference in the thrust method. So I want to do that one because it's potentially, I think it's potentially less processor intensive. Luckily, as I understand it, calculating sine and cosine like this has gotten much less processor intensive over the years. and in JavaScript even in JavaScript, it's not so bad. So it shouldn't be terrible to be calling that every frame that we're turning the ship. Just as we're applying thrust to the ship, the way I see it, when we call thrust on the ship, we're not necessarily turning. We don't need to recalculate these. So I think the logic holds that we only calculate the sine and cosine when they change, which is when you turn the ship. You could argue that you should only calculate them when you need them, which is when you're thrusting the ship. But I would say that maybe that's arguable. If we were rendering our ship lines, for example, if we were rendering in a different way, maybe that would make sense. But for the way this is all set up, I'm going to do it this way. So what we can do here is I'm going to say I'm going to have like an x velocity and a y velocity. We're going to calculate those. And of course, I could tighten this stuff up to be only 2 lines, I think, of code for this thrust method, but for clarity's sake, I'm going to space it out a little more. So our x velocity is going to be the current cosine times ship thrust speed. Actually, you know what? I'll modify that later. I'm getting ahead of myself. Ship thrust speed, which we should define up here. This is going to be in pixels, so I'm going to say 32. Probably, again, that's probably too slow, but when you're testing things like this, it's better to be too slow than too fast, because if it's really slow and sluggish, you can actually see what's going on and pick out errors that might be happening. So cosine always relates to the x-axis and sine to the y when you're multiplying by coordinate points. So here's our x velocity, here's our y velocity. It's all great. So what we want to do is this. Oops, we want to do this dot x plus, plus equals, I should say, this dot x plus equals velocity. Let's say delta times velocity. And then the same with y. Delta times y velocity. So there we go. There's our thrust method, which we ought to call in the process method. And of course, since the we want to call thrust after turn, because our turn method updates the sine and cosine, and thrust requires that. So we want to call turn first and thrust second. We're going to have a slight problem. First, before we get any further, I'm gonna effectively duplicate all this stuff to make sure that I might even just copy this. So what I'm going to do here is I'm going to copy down from the asteroid our little code to wrap the object around the edges of the screen. And so, yeah, I'm actually going to do it this way. Let's do it this way. So we're going to have we're going to do our next x and next y like before. Let's do this. Our next x and next y. Let's see. I'm not going to do asteroid size. I'm going to wait until. So before we had, the scaling asteroid size so that the asteroid would go entirely off the edge of the screen before it looped around. Hang on. The player ship is so small that I want it to wrap as soon as the center goes off the edge of the screen. So instead we're going to get rid of all of those. And we're going to just say, when the x is less than 0, we add the canvas width. When it's greater than the canvas width, we subtract the canvas width. and the same for the Y position and the height. So this is looking pretty good. We calculate what the velocity should be per second. We multiply the delta by it. Oh, that's right. We want to do this dot. There we go. I'm glad I went over this because I would have got it wrong. So we calculate the velocity in each direction. We add it to the current x and y positions multiplied by delta, of course. Then we check to see if we're off screen and wrap around back onto screen if we are. And that's all we should need to do. It's funny, I just realized that this mirrors the rotational clamping that I did before. We're effectively keeping the ship's position within a certain bounds in the same way that we're keeping the rotation in a certain bounds. So let's go back to the scene. And before I refresh the page, there's no user input connected to thrust right now. It's just going to, the ship is just going to go at full speed ahead. And as soon as I refresh the page, it should do that. Unless there's an error. Oh, I see. I must have missed a comma somewhere. Let's switch back to the, let's switch back here. I missed a comma or a closed brace or something. I'm just going to use the editor to help me find it. Oh, it's here. I forgot a comma in the plain JavaScript object, of course. Now let's go back, and if I refresh, there's our ship. It's going very slowly, like I thought. But it's going straight ahead. If I turn, it starts going in the direction that I turned it. Nice and easy. So let's go and see what happens when we hit the edge. There we go. We just snap across the entire screen to the end. And I do have W connected with that input status. But of course, I'm pressing W now and nothing happens because we haven't hooked it up to anything. So this is great. This is working. And we only have one simple step to connect our input status, pressing the W key, to our ship actually moving. So we're going to say this dot speed equals 0. And I'll make sense of this in a minute. Speed times. There we go. So our ship's speed starts at 0. And we multiply it by like the thrusting speed, which is our, I guess that's going to be our maximum speed. And all this other stuff. So we put this in the function, and now if I hop back into the browser and refresh, there's an error. Why is there an error? Did I typed it in wrong? Oh. Don't pay any attention. I forgot the obvious thing, which is that speed is not a variable defined anywhere. It needs to be this dot speed because it belongs to the ship object. So now we don't move forward anymore because our speed is 0. And luckily, we can add some new logic to the process that will decide whether to go or not. So I'm going to say if input status thrust, we're going to say this dot speed, let's say plus equals 4. Oh no, you know what? Okay, if input status thrust, right, if speed is less than ship thrust speed, oh no, if ship is less than 1, okay, okay, let's back up. Okay, so the speed should be the ship's current speed. Let's make it simple and like easy to read. Thrust speed, I'm actually going to rename this. We're going to say ship max speed, like that. 32 is too low. I'm going to bump it up to 128, which is substantially higher. So I'm going to say if the speed is less than maximum speed, we add 4. It shouldn't be that, though. It should be delta times 4. So this is our acceleration. Our acceleration rate is 4, and we should probably codify that in a constant. So I'm going to do that. Ship acceleration. Sorry, const ship acceleration. And I need a space in order to autocomplete for some reason. I'm going to make it a floating point just because we might. I'm sure I'm going to want to tune that a little bit. But now, as long as the thrust key is pressed, our ship will accelerate up from 0 towards the maximum speed. I should do it like this, though. Hang on. We should do math min. Oh. Oops, mistake. I'm hitting page down and stuff by accident. So what we should do is this. So we're adding the ship acceleration to our current speed every frame if the thrust key is pressed. And this math min is just to ensure that we don't go higher than the maximum speed. It should be, except that I put the wrong variable. There we go. So it should be, as long as the key is pressed and we haven't hit the maximum speed yet, we'll keep adding acceleration. Else, this dot speed, actually I should do else if this speed greater than 0. We'll do the same thing in reverse. Speed minus delta times ship acceleration. Probably the so this, if the thrust is up, is not pressed, and speed is greater than 0, then we reduce it. We slow down. Or we would. I'm going to comment this out for a minute, because I like the idea of a ship. I might even leave it commented out, because I like the idea that the ship will, that there's no friction in space. Except for the turning, obviously. We've made the turning, we've made sure that the turning speed slows down, that you stop turning when you release the button. But we don't have to do the same for thrust, and I think that will make it for a much more chaotic experience. So, if I refresh the page, we're sat here in the center. We can turn left and right like before. If I press the thrust key, we slowly, yeah, acceleration is way too slow. We slowly speed up. And if I let go, I've let go, and we are still moving. That's right. If I want to do this, then I should do it differently than I have. I should add, I should actually do a physics component. But this kind of does what we want. I'm speeding up. I'll do, just to make things a little easier, I'm going to bump up the acceleration about 4 times, which I have a feeling that even that won't be enough, really, but I'm going to do that for now. If we want to have more believable, sort of outer space physics, we need to keep track of the ship's velocity in both x and y directions and only change it when you apply thrust. So I think that's what I want to do. Let's keep everything the same way it is now. We're not going to have this because we don't need it, but I'm going to add some more stuff. So I'm going to ultimately get rid of this speed property, but for now, let's do some stuff. So we're going to have x and y velocities, and okay. Right. Oh, maybe we do want to have. No, you know what? Okay, let's comment this out and this. And what we're going to do is... boy, I'm trying to remember how I used to do this, because I've made this kind of project ages ago. So if we're applying thrust, you know what? I should. Okay, let's put this down. This should go in the thrust method. Probably this should go in the turn method as well. But for now, I'm just going to focus on the ship thrust stuff for now. So if input state dot thrusts, we can do this, and oh no, you know what? My mistake. Really, what we should do is have this. This is our move. This should be our move method, because we always want to be whatever the velocity of the ship is. We want to be moving it all the time. We only want to change the velocity if we've applied thrust. So that's the change. The change is the move method is always moving the ship based on its current velocity, which I'm going to change these. This is going to be this dot xvel and yvel. I always shorten velocity to VEL just because it's a little quicker and easier to read. Quicker to type, really. And all we want to do, this dot xvel and yvel. We've deleted speed though, so I guess we can reintroduce this ship thrust. We can reintroduce this. We can reintroduce this property. This is getting all over the place. I'm going to say this is 128. Oh. I'm a fool. So what we want to do is we want to add... no, I do want to ship thrust speed, though. But, so the way this will make sense... This will make sense in a moment. Okay. Thrust speed should probably be less if we're adding it every frame. Potentially this can spiral out of control until our x and y velocities are crazy high. So we could clamp it. I'm going to do just that. We're going to do this equals math min math max. So I'm going to pick an arbitrary maximum and minimum speed. Let's say 2048. And then I'm going to do sort of quote min speed. I'm just going to store those at both the positive and negative one, just so that we don't have to calculate that every time. So there we go. So it may look a little backwards to have the max speed in the min function and the min speed in the max function, but max is saying give me the bigger of these two numbers. So if our xvel, if our new x velocity is less than the minimum speed number that we should have, we cap it at the minimum speed. If it's greater than, you know, if the maximum speed number is less than, whoops, I didn't know you could click and drag like that. But if this maximum speed number is greater than the ship's current thrusting speed, we pick the smaller one, which ends up being the maximum number. So we clamp. This is how you clamp stuff in JavaScript, because there's no clamp math function. You have to just use both of these in and of themselves. This will take some testing, of course, but I think... Oh, you know what? I should do delta. I should include delta in this. We should be adding delta times cosine thrust speed and delta times sine thrust speed. Okay. So what this should do is whatever the current x and y velocities are, we use the current facing direction, cosine and sine, and the ship's thrusting speed to apply thrust in that direction. But we only do that when the thrust button is pressed. If the thrust button is not pressed, the ship will continue to move in whatever its current x and y velocities are. That's the crucial thing. That's how we get behavior that is like, a hovercraft or outer space. I think we're not using this anymore, yeah. And we are using these. Okay. I have a feeling that there's some other variable that I am no longer using and I should delete, but I can't remember what it would be. Anyway, we have our W key. We're just toggling on and off our input status with it. That's fine. And we should be good to go. So right now, what we should see in the browser once I refresh is an error. What's the error now? 183. Let's go back. Let's go back and see. I have to expose my flaws, my dumb mistakes. So there's an error here. Oh, I didn't put another close parenthesis. It's the way these editors will autocomplete stuff sometimes. Okay, so we have two closed parentheses to match the two open. Now it should be fine. We're fine. So the ship isn't moving because our velocities are 0, but I can add a little bit with the W key, and I've let go of the W key and we're still moving. And now before, when I turned, the ship started to move in its facing direction, but now you'll notice we're still moving in the direction we were going before. This is the kind of behavior that I want to have for this game. So if we want to slow down, we can face opposite the direction we're going in and press the W key and we'll slow down to a crawl and then start going the other direction. And then we can turn and start going in this direction, and you'll see this kind of creates a little arc as we're moving. And I can sort of slow down and turn this direction, and so on and so forth. So there you go. Now we've got basic player input and forward movement. I'm going to try tweaking the numbers a little bit. I think I'll hold on the browser for you all while I change the ship turning speed. It's way too slow. I might also need, that's a little better. It would be nice to have some easing on it because right now it just goes it's either 0 or full speed. The thrust acceleration is a little slow too. So let's change that. Currently at 64, let's do 128 and see what that looks like. So we're turning. That's still a little slow. I'm going to bump it up another 2 times to 256. There we go. Let's, for the sake of experiment, let's actually see what the maximum speed looks like. I'm just holding down W and going and going and going. Boy, it's hard to follow now. It's going so fast. I feel like that's got to be maximum speed. And that feels too fast to me. So let's drop it down to a quarter of that. Oops, I shouldn't turn. I'm tempted to turn because it's fun. It's more fun to like move around like that. Okay, this feels a little fast, like a little uncomfortably fast based on like the outer space physics, but I think that's a fine top speed. So our top speed in either, it's a little inaccurate technically. Our top speed in either axis is 512, but together, if both your x and y velocities are 512, then your actual speed is going to be more because you combine those into the direction you're facing. So technically this isn't our actual max speed, but it'll do. It's oversimplistic, but it'll do for our purposes. Technically we'd have to do some more stuff about like, we would actually have to calculate the speed we're going in the current direction. And that's a whole extra effort that I'm not really willing to do right now. So Boy, what's next? Well, we need some collisions. And luckily, a game like Asteroids is simple enough that we can do just simple circular collision. I think I teased that in the asteroid object when we, in the first part. So let's actually play that out. So I've got this dot scale and asteroid size. So this asteroid, I defaulted this asteroid to be a scale of 3, although probably we should have that like asteroid scale. We should have that as a... We should do something like this. Oh, come on. There we go. We should have that as a property that we assign when we create the asteroid. So in my test asteroid, I'm going to give it property of 2. And now if we reload this asteroid, which you can see how big it is here, it should be smaller now. Yeah, a lot smaller because I gave it a property of 2. That doesn't seem right. It looks like it's only 1 scale. Yeah, I screwed something up. Oh, I did my ternary operator backwards. Okay, I set it back to 3, so now it's the full size. There we go. So we can use the asteroid size constant and the scale method, the scale member property to determine whether we collide with anything. So there are 2 ways to do this. We can either have, or there are a few ways we can do this. We can like check overall. We can have like a sort of a, each object itself checks when it's bumped into something. We can have each object, only certain objects checked if they bumped into something, or we can have some kind of global process that checks everything in the scene and sees whether anything is colliding with anything else. I think for our purposes, that last one is probably the most robust. It also allows us to determine what order we check these things in. Because if we check, if each asteroid detects whether it's collided with something, and it collides with more than one thing at once, then certain things will get priority. So yeah, let's go through that. Let's have a, I'm going to call from here a function that I'm going to invent in a minute. We're going to do, let's see, we're going to do handle collisions. We're just going to do that. It doesn't need delta because it's not actually processing anything. But we're going to declare that function. We're going to define it up here. So we only have a few objects in the scene right now, the test asteroid and the ship. So I think we can, there's probably a smarter way to do this where we have like this function itself accepts objects, accepts parameters, so that it doesn't have to be kind of hard-coded into the whole program. But I'm going to do it the kind of easy way and say, you know, we're going to have our ship and our test asteroid. Or not even. I'm actually going to make an asteroids collection, which we can flesh out later. Whoops, wrong bracket. I'm going to have an asteroids array, even though it only has 1 element in it. We're going to have this list of asteroids, and we're going to just run through them one by one. Come to think of it, I can probably, I don't know, I don't want to do that. I know there's another syntax for iterating through objects, and I'm hesitant to actually use it, even though this is an array, because it's I think you can technically iterate through all the properties in an object, and that's not what I want to do. So for our asteroids, we want to see, we want to add a new function. So let's do this. Let's say does, we're going to have a is point inside. And that's going to be a function. Oops. My goodness, function. I got to spell correctly at some point. And we're going to have an X and a Y coordinate. So I think by default we're going to say false. But this function, we're going to ask the asteroid if a given coordinate point is inside of its radius, inside of its space. So if the ship, I want to be lenient. I want to make this game not too difficult. So I'm going to use this rule where the only collision on the player ship is the very center point of the ship, not rather than creating a circle on the ship that's collision or something else. That keeps it simple for us as well, because we can just say is point inside, and all we have to do is we can get x distance. We can get the distance from the center of the asteroid. We can get the distance from the center of the asteroid, and if it's smaller than the asteroid scale multiplied by the asteroid size constant, then it's inside. And if not, then it's outside. It's even simpler than that because, as you'll see in a minute. So we got our x distance and our y distance, and so we can say dist squared, oops, x distance times x distance plus y dist, oops, times y dist. So we're using Pythagorean theorem to get our distance in a two-dimensional space. And normally with Pythagoras, what you would do is x squared plus y squared, then calculate the square root, and that's your distance. But the funny thing is we don't actually need to calculate the distance. All we need to know is if this distance from the asteroid is smaller than some other distance. So what we can do is radius squared, which we might even create. It might even be worthwhile creating this as a member property. But this is a time saving, at least this is a processor saving operation we can do. Yeah, you know what? I'm actually going to do this as a property of the asteroid. We're going to say this. Yeah, okay. Radius squared, oops, squared. Radius times radius. There. So our asteroid knows its radius squared. And we can call on it. So now what this does is that a square root calculation is actually quite expensive, and we're going to be calling this function every frame on every asteroid in the scene. And if we have a lot of asteroids, we're going to be making square root method calls a lot. But we don't need to, because we don't need to actually know the exact distance. We just need to know comparative distances. And you can think of it this way. If the point is inside the asteroid's radius, then the square of that distance is going to still be less than the square of the asteroid's radius. Same thing if it's outside of the asteroid's radius. The square of the distance is going to be greater than the square of the asteroid's radius. So all we need to do, and actually I can remove this line. I don't know why I had it there. we can say dist squared less than radius squared. And that is our entire function for collision detection on an asteroid. Super simple, it's great. Basically, anytime that you don't need to calculate a square root, you should not calculate a square root. And this is just an easy way to avoid it. So back down here in our handle collisions function, we're looking through all these asteroids, and I'm going to say asteroids of this index. We're going to do is point inside, and we're going to say ship x, ship.y. And if it is, then we need to do something to our ship. Maybe the simplest thing is to... so I think we want to... I said before I wanted to be lenient with the ship's collision, but I think when the ship gets hit, it's going to be destroyed. There's no health in this game. You are just destroyed. So what we should do is we should give the player some number of lives, maybe? This lives. Well, I'm getting ahead of myself. What I should do is player is alive. Because we're going to destroy the player when it gets hit by an asteroid. But if it is, even if it's gotten hit by the asteroid and destroyed, we're still going to be getting a true for this check while the asteroid is still moving across the player, if that makes any sense. So we do want to have this extra stipulation. We want to say if ship.is alive and is point inside. So we first check to see if the ship is even alive, and then we actually run our method on asteroids. So if the ship is alive, let's say ship.kill, and we're going to actually write a method on the ship that is called kill. Well, you know what? I kind of mixed up the order. I think process should come after these other ones because process calls these functions. Okay. Next, let's do our kill method. Kill. So what does our kill method do? Well, I think the first thing it should do is this dot is alive equals false. Oops. Then we should, we need to do something to make the ship return to life. So let's see. How about, let's add another function called revive. And that's going to do this dot is alive equals true. Nice and simple. And in our kill function, we're going to additionally say set timeout this dot revive. That might be a problem, but we'll see. This is where JavaScript problems start to rear their ugly head. But for now, I'm just going to say this dot revive, and then we're going to make another constant. I'm going to say ship revive delay. So after a given number of milliseconds, the ship will revive. Let's say I'm trying to pace out how long a second is. Let's say 2.5 seconds. This is in milliseconds. There we go. Right. So after the ship is when we kill the ship, we set is alive to false. Ship revive delay until it returns to being alive. This flag, this ship is alive flag, we should actually use in other places as well. For one thing, right now in the render function, we're just drawing the ship every time, but we should be calling our ship. We should be calling a render method on the ship. Also, it just occurred to me that making the asteroids into an array means we have to do a bunch of extra stuff like this. So let's come back to that in a second. We've got our player process. Okay, player prototype render. There we go, and we can do, instead of, oops, I must have click and dragged a little bit. We can do this to get all this stuff. Oh, what's the 0.75? I don't remember. Is that my scale? It is my scale. Yeah, because I was too lazy to change the drawn points, so I added a scale to shrink them down. I forgot about that. Boy, me and my laziness. Speaking of which, I'm going to copy this for loop declaration down to both instances where we need to loop over the asteroids array that I've created. Asteroids.I needs this too. I'm going to do a quick search for test asteroid just to make sure I've gotten all instances of it out of here. With a capital A? No. Case and sensitivity. Oops. Okay, cool. Good. We got all of them. Hopefully there should be no other problems. The advantage of creating this render function, this member function on the player object, is that we can do this. We can say if this is alive, render draw line segments. So if it's not alive, then the player disappears. That'll be a good visual indication to us that the kill function has worked. So let's return here, and luckily there's no errors. Good, I was ready for an error this time. Now here comes the asteroid, boom, we disappear. And in a few moments, we should come back. Nope. This might be where things rear their ugly head. So, the ship didn't come back. Oh. Well, okay, I'm going to have to do this demonstration again because I forgot to switch to the browser. Okay. Here we are. Again, attempt number 2. Here we are in the scene. Everything's working. Let's crash into the asteroid because I don't want to wait for it to hit me. Here we go. Oop, and we're gone. We're gone. The ship is no longer here. And we're waiting, and the ship has not reappeared. Even though by now it's been over 2.5 seconds. So what happened? Well, that's a problem with JavaScript. The problem with JavaScript is, so we called this set timeout. Set timeout is a simple function. You use it all over the place. It'll call this function after this many milliseconds, right? Simple. Problem is the word this and the way that JavaScript handles context, because when this kill function gets called on our ship object, ship.kill, so on, when our ship gets killed with that function, this refers to our instance ship. When this.revive gets called, or sorry, I'm talking about the wrong thing. If we called ship.revive, right? If we call it ship.revive, this inside the revive function refers to ship, our instance of ship. However, when set timeout queues up this.revive, it is still this function, ship.revive, ship player prototype.revive, but when it gets called, this no longer refers to our instance of ship, it refers to the window. I don't know why exactly, but that's just the way this seems to work. So we have some options. One way is to say bind this, which what this does is the bind function, it creates a copy of this function, and then it binds whatever you put in here to that function as the context, in this case the word this. That's the easiest thing. And if there are other ways, like I could create like a ship timing out function that like I could create kind of a timer. I could create like we could, make, ship revive timeout. And then whenever we call the process method on the ship, if ship is not alive, tick down the timer. And then once it reaches 0, then we call the revive function. For now, kill is not going to be called out that often on the ship. I think we can use bind this. Creating a copy of this function is not going to be so bad. If this was a function that we were going to call a lot, then we wouldn't want to do this. But it's infrequent enough that I think it won't be a problem. Before we go any further, though, I am going to move the turn direction stuff into the turn method. Here it is. And then in the process method, I'm going to do this. I'm going to say if this, is alive. Because in the render method, we only render the ship if it's alive. We should do the same in the process method. We should only turn and move the ship if it's alive. So let's see, when we revive, I think before we make the ship alive again, well, we'll see. For now, all I've done is I've fixed the problem where the ship should come back now after about 2.5 seconds. So let's refresh. Refresh the page. I'm probably going to have to move the ship again to get hit. Yeah. Where is it coming from? It's coming from there. Let's go this way. Now let's do this. Let's go. Bam. There, we hit it. And now we're back. But you notice we had the same velocity and facing direction that we did when we were destroyed. And that doesn't seem right, does it? Luckily, we created a function called revive in which we returned the ship to life, and we can kind of reset some of its values. So for one thing, let's do something like this where we no, maybe that'll be fine. Let's see. Sorry, I'm getting ahead of myself. What we should do, we should have like, oh, you know what we could do? Okay. We could reinstantiate the player ship object, but I think maybe that's not a great thing to do. Let's keep the object in memory, so as it is. So instead, we'll just reset all of these properties, I guess. Because that's the thing, we could instantiate like a new player. This is so repetitive. I don't want to do it like this. Hang on. Let's see, let me think. I think we don't want to reinstantiate the ship object inside a member function. That seems like a mistake. You know what, let's do this then. Oh, you know what? Okay. I'm jumping all over the place. So currently all of these need to be reset to their starting values when we revive the player ship. But we may add some properties that need to stay the same after the player's died. So I'm going to say reset we're going to have this function called reset, which I'm going to call when we instantiate the ship. So when we instantiate the player ship, we're going to call this reset function to set all of the necessary stuff. And then when we revive, or even instead of reviving, we can just call reset. Our reset method can be the one that sets all of our default settings. And the one that we use to revive the player from being dead, because we set this dot is alive to true in our reset. Okay, I've solved my own problem. Now, if we go to the scene, we reload again, I'm going to try and run into the... Oh, I don't even have to. It'll hit me. That's not the best example, though, because I should be moving. So let's be moving when the asteroid hits us this time. And boop, it was hard to see, but I disappeared here. And now I'm revived here in our initial orientation with no velocity. And that asteroid came really close. You might have even seen part of the lines overlapped the ship a little bit, and that's because the actual render of the asteroid is a little bigger than our collision circle, but that's fine. I think that's acceptable, and it's that sort of leniency that I was saying I wanted this game to have. So we've got all that handled. That's great. I'm actually going to, now that we have this asteroids collection, I'll leave it alone for now. I'm going to build out the asteroids a little more in a bit, but for now, we need an ability to destroy asteroids. So we're going to make a new object. Let's call this laser? No. Plasma bolt. We're going to start with an X and Y position, sine, cosine. I'll do cosine sine. And you know what, I'll flip these around, because I always put X first, and cosine corresponds with X, so cosine goes first. So our plasma bolt is going to be what we shoot at asteroids. We're probably going to need plasma bolts array as well. I could make it one that belongs to the player as well, but for now I'll just have it here. So, plasma bolt. This.x, we just assign all this stuff. It'll make sense in a minute. Oops. So, what we want to do is we want to instantiate this bolt where the player is. Maybe a little bit ahead of it. In fact, let's see. I'm going to say like 8 times cosine and, oops, and about 8 times sine, because that's about our ship. I think our ship protrudes like about 20 or 12, I don't know, basically 8 pixels from the center of the ship forward, I think. Oh, no, that's not right. For now, we'll just keep it in the center of the ship. Oops. For now, we'll just keep it. It'll just spawn in the center of the ship, and I'll get fancy with its positioning later. So we want to have, right, X velocity, Y velocity. What I should have been doing with the player is I should have been attaching these constants to the player object. So I'm going to do that with our plasma bolt. In fact, I might actually even do that here. We're going to do player dot, and we're going to make all of those like that. So ship revive delay needs to be player dot ship revive delay, I think, or maybe it can be this. I think it can be. We'll see. We'll see if it breaks when we actually reload the scene. Have I done anything with the plasma bolt? I haven't. So I can test this really quickly. Let's see, I've got min speed, max speed, revive delay I did down here, thrust, and turn speed. Where's turn speed? There it is. I think that should be fine. The advantage, of course, is that I'm going to shorten all of these names to be just min, max speed, turn speed, thrust speed. Let's see. Nope, that was not fine. Something's not fine. 154. Oh, oops. I put function twice. There we are. Okay, I think this is not the correct keyword. But that's fine. Instead, we have to do player dot, and we'll do max speed. Oops. And we'll do the same here. It doesn't save that many letters, I guess, but we've kind of encapsulated... We've encapsulated the relevant... we've encapsulated all of our relevant constants inside the class. It's the closest thing you can get to it's the closest thing you can get to class variables in JavaScript. So let's do player, right? Player.revive delay. And then if I go back to the browser, everything should be fine. I'll have to run into the asteroid just to make sure it works. Oops, I missed it. It's almost as hard to hit the asteroid as anything else. Playing your own game can get quite tricky. There we go. I've hit it, and I revive in the middle. Okay, I think everything is working. So, that was a prelude to what we're doing with the plasma bolt, because it only makes sense that these properties are only being used by the player object, so they may as well be class properties. So I'm going to do that here. We're going to say plasmabolt.speed. It should be faster than our player, higher than that maximum speed. So I'm going to say 1024 in pixels per millisecond. I could even do this, pixel per millisecond. So our x velocity, we can calculate this straight away. It's not going to change. Cosine times plasbolt.speed. Cool, and we do that with sine as well. We do store the cosine and sine so that we can draw the plasma bolt. Let's do the same plasma bolt.lines. We should create, like we did with the ship and asteroid, we should create some lines here too. This one I'm going to leave as a global variable just because I might do something fun later. Something that I did on my website was that I made a version of Asteroids where you could change your ship to look like different famous spaceships. Some looked better than others. They were all kind of like hand vectored by me, so I think I tried to do a Millennium Falcon and it looked okay. As well as the Serenity from Firefly, excuse me. So plasma bolt lines, this should be pretty simple. I think we're just going to have a straight line actually, so it'll just be two coordinate points, coordinate sets. We want it to start at the front, so I guess it'll be 0, 0. And then x can go like negative... How many pixels do we need to see it? -8 and 0y, something like that. Right. So let's start adding some member plasma bolt prototype render. We'll start adding some member functions. What is it? Draw lines, segments. There we go. Plasma bolt dot. Whoops. There we go. Lines. Boy, I'm trying to remember how I defined my my function for drawing lines. Right. XY segments, theta, and scale. So we want this x, this y, lines, theta. Oh, that's right. This dot theta and scale. I think we can leave that blank and it'll be one scale. So I was wrong about sine and cosine. We don't want to store those. We want to have theta instead. Which, now that I'm thinking about it, since we can, theta is really only useful for turning the ship, turning our player's ship. Sine and cosine are a little more reliable. The asteroids don't spin right now, so we could just calculate sine and cosine right away. The bolt isn't going to spin, so we could do the same, and we could simplify our draw line segments method by allowing us to feed in the sine and cosine instead of theta. But for now, I'm just going to do this. So plasma bolt render function, great. We also want to have process. There we go, and we need our delta. Oops. And this one is going to be way simple. We're going to do this dot x, next x. This is going to be the same as the other processes. I'm going to even clamp the position so that the bolt wraps around. So we're going to say next x equals this dot x plus delta times this, this dot x vel. Oops. And then next y equals y plus delta times y vel. Luckily, the x and y velocities don't change, so we don't have to do all that much. I'm going to copy over the player thing again, because actually this ends up being identical. Because I'm using the same property names, we don't even have to change anything, and everything should get assigned. Although this needs to be next y. Oops. Capital Y, thank you. Whoops. Goodness, I'm just slipping all over the keyboard, hitting all the wrong things. Okay, I don't know why I had next x twice by accident. But anyway, we've got process and render. Great. So now what we can do down here, way down here, is we can kind of do the same thing that we have with asteroids, and I'm going to move it under the ship. And just plasma bolts. And then we can have in our render function, we can do the same thing again. Boop. Plasma bolts. Done. So now we have our plasma bolts hooked up and ready to go, but I don't have a way to fire bolts. So let's add that case. Let's do the spacebar, even though potentially that's like going to be the noisiest option and the most strain because it's the biggest key on the keyboard. But it's a common, spacebar is like a common do things key. I guess we could use control. That was like the old way of stuff. But then for whatever reason, keystrokes that are not like letter inputs are a little bit harder to register in the browser. You have to like check, I don't know, checking if like the control shift or alt key was pressed or released seems to be a little weird. I'm not going to worry about it too much. So rather than doing input status, oh no, I will absolutely continue to use input status. Okay, input status, fire plasma, or let's say fire. True. Good grief. I can't type today either. I don't know what's wrong with me. I'm just accidentally hitting Control F to find stuff and zooming all over the page. What a mess. Also, I should have done this. I didn't realize the gutter was so wide there. The like folder, the file list. So going back up to plasma bolts, we want to have Or no, we really should just have a fire method on the player, right? So in the process, if the player is alive, this stuff fire bolt. So we're going to add a new method to the player. There. You know what? We can just do this. Fire bolt function, and in this function, we make a new, whoops, goodness, my goodness. Oh, you know what? Yeah, I'm gonna actually wrap this in a conditional, because this one's not gonna happen as often as moving and turning. So we're gonna say if input status fire, which I need to add here, fire false. Maybe I'll put it down at the bottom so that they kind of, thrust, turn left, right. They kind of line up. I guess right should go first then, actually. Thrust, right, left, fire. They're out of alphabetical order or anything, but just kind of in the order that I've been making them, I guess. So if input status dot fire, fire bolt. Right. We'll deal with, there are problems with this, but we'll deal with them in a bit. So we're going to have new plasma bolts. Our bolts equals new plasma bolt, and we need to have this dot x, this dot y, theta, cosine, sine. Right. It occurs to me. No, you know what? It's fine. If we really wanted to, we could also pass the ship's current velocity, x and y velocities, into our new plasma bolt and give it some extra momentum when it's being fired. For now, I'm not going to do that. No, for now I will do that. Okay, for now I'm going to do that too. At this point, I should just pass the whole ship in there, shouldn't I? Because I'm adding so many. I'm passing in so many functions, so many objects. So yeah, let's do that. For our plasma bolt, I'm getting kind of lazy here. We're going to pass the whole ship in. Ship dot theta. Great. So we're going to do this. We're going to do yep. Ship dot xvel plus plasma bolt speed in the relevant directions. Okay? Okay. So now whenever the fire button is down, every frame we're going to create this new bolt, this plasma bolt. So plasma bolts, push, bolt with a T. Now what we should do is we should have like a fire delay. Fire countdown greater than 0. Right? Okay. And we do fire countdown minus equals. So what we should do is we need to have a fire delay so that we're not firing every single frame. And to do that, we're going to have a new property on the player ship object, which I guess we want to have get reset. Yeah, we want to have that as part of the reset for sure. So firebolt. I guess. Okay, I guess I was wrong. We want to be calling this firebolt method every frame, because what we're doing is we're tracking our fire countdown. Every frame we're tracking the fire countdown, and then we're going to actually decrement it if it is greater than 0. Well, that's right. Fire countdown equals player. Oh, you know what? We'll call on the plasma bolt for fire delay. So the plasma bolt object will have its own fire delay property. Oops. Put a dot in there for crying out loud. Let's see, what delay should it be? Maybe 0.25. Because our delta is in seconds, right? It's confusing because the frame, the timestamp that we get in our frame step is always going to be in milliseconds, and I'm converting it with the delta into full seconds. But there are some instances where we are still using milliseconds because of the way that JavaScript is built. So I need to constantly shift. I need to constantly convert between those two values. So our fire delay is in, in seconds. Right. So this should work. If our fire countdown is greater than 0, then we subtract delta seconds from it each frame. Then we need to say if it equals 0 and the fire button is active, the fire action is currently on, then we try to fire bolt. I'm going to take an extra step and say if, because doing the equals, an equals comparison is pretty is faster than doing a less than, or a less than and equals. So I kind of want to do like if fire countdown is less than 0, we set it equal to 0. I don't know. For all I know, this is actually slower doing all of this extra stuff than doing just a less than equals. So who knows? Who am I to say? I do want to make sure to, one little trick, and I may have mentioned this last time, one little trick that I haven't been doing apparently, is that when you instantiate a variable, when you initialize a variable with a value, I should say, you hint to JavaScript and the compiler like what value, what variable type it should be. So in the instance of these velocities, we need them to be floating point values, so I should say 0.0. Turn direction, though, only needs to be an integer, so I can say 0 without a decimal point. And the interpreter will guess what variable type it should be. The thing being that once you declare a variable of a different type than the interpreter thought it was, it'll have to create a new variable in storage and assign the new value. So it saves a step to do that. So I think I've got everything set up. Let's look at it in steps. So we have our input status fire. If I press the spacebar, fire is true. And in the process, if the player is alive, we call this firebolt method, which I should really rename that. Let's see. Handle weapons. Let's say that. Handle weapons. Fire count. If the fire countdown is greater than 0, we deduct from it until it goes below or equal to 0. If it's already at 0 and fire button is down, we create a new plasma bolt using the ship object as a reference. And we add it to the plasma bolts collection. And then we also make sure that we set the fire countdown to the plasma bolt's fire delay. The reason that I've done it this way, where you have plasma bolt.fire delay, is if we want to change weapons or something, then what you would do, we would have some kind of extra object that's, we would have, like current weapon equals plasma bolt. We would have this somewhere up higher, and then, you know, we would call new current weapon this and current weapon dot fire delay. And as long as whatever weapon we assigned to current weapon has a fire delay property and can be instantiated with the ship the way the plasma bolt can, we can just assign any similar enough weapon. And the player object doesn't need to know what that weapon is, it just fires it. It just instantiates it. For now, we just have the one, though. And I'm probably not going to make any more, because it's a very simple game, Asteroids. And it's high time to return to the browser and see what happens when we press the spacebar. Boop. Nothing. I just got destroyed by the asteroid. So I press the spacebar, and nothing has happened. I wonder why. Well, here, so you can see it, I'm going to put the debugger on the screen. So let's do a little debugging and see what happens in the fire method. Scrolling way down here. Handle weapons, here we go. So I'm going to go here, because we should end up on this line if I press the spacebar, right? Spacebar. There we go. So we've reached this line. We've created this plasma bolt. Plasma bolts already seems to have a long list of objects in it. We could investigate that, actually. Let's see. Let's look at that first one. It's got an X and Y position. Velocity. Its velocity is really high. Wow. 1,000. This is a reason. This is why it's a good reason to start with low numbers, like I was saying before. So maybe I need to do that. So I think we just can't see the plasma bolts for some reason. That's what my thought is. So let's go back. Let me reinvestigate, actually, my rendering method. Draw line segments. So we do length plus equals 4. So we move to line 2. That should work. Well, here's a thought. I'm going to do two things. One, I'm going to change the... I'm going to cut down the plasma bolt speed. Let's put it to 64. And in the render method for plasma bolt, I'm going to instead do ship lines so that we instantiate a player ship, or so that we end up seeing a player ship instead of the asteroid. Let's see. Or instead of the little tiny thing that we made. Also, I need to make sure that I'm focused in the document. Okay. That's so weird. I click the space bar, and nothing happens. Am I actually rendering? That's the question. Easy way to find out is to debug again. Let's go back up to plasma bolts. Here we go, render. So our ship lines is that, theta. This Y is 108, 220. Hum. I'm confused. Let's look back at the code. I'm sure something will pop out. Because let's see, how are we rendering the player again? Draw line segments. Oh, is it the scale? Hang on. Draw line segments scale. Okay, I have a thought. If scale, let's say if not scale, scale equals 1.0. let's do that. And then we'll see if that... I just assumed that I could leave the scale blank, and I probably can't. There we go. That's... So now it works. Sort of. Let's revert back to what I had before, so that we're rendering plasma bolts instead of, you know, a full-size version of the ship, and it's also going at the speed I prescribed. Okay. So now we're in here and we immediately get crushed by an asteroid. Not a great start, but bam, there it goes. Look at that. And it keeps going and going and going. It's very fast. And we can keep firing them about that fast. And look at that. Now you may notice a problem, and that is that the bolts do not go away. So we have to do something about that. I think we can actually use the set timeout method again. So let's go back to our code. And in the plasma bolt, we can create a familiar looking function called kill. Functino. Boy, I don't know how often I do that. I type functino instead of function. But, yep. Plasma bolt prototype.kill. Oh, actually, I'm not sure how to do this. I think... Because, the funny thing is, as far as I'm aware, in JavaScript, there isn't really a way to destroy an object from the inside. Maybe there is, but there's, you normally would call, like, for this asteroid, for example, like you would normally call destroy asteroids, you know, 0 or something, or delete. I know that delete works for certain member properties on an object, but I don't think we can actually remove the plasma bolt from within its own thing. So yeah, we have to do something a little more complicated, at least as far as I know. So I'm going to say this.life, lifetime, oh, good grief, lifetime equals plasma bolt dot life. Oh, you know what? Let's say lifetime, and this is life. Right, so we're going to do something like this just to save typing. And we're going to say that the plasma bolt's lifetime in seconds is how long? This is going to work like the fire delay, incidentally. I think 3 is probably good. So when we instantiate a plasma bolt, we give it a lifetime defined by the class, and then every frame we process it, we do this.life minus equals delta, cool. And then we do all this other stuff. The thing is that down near the bottom, which, come to think of it, I think we should have a process, a global process function to put everything inside. So I'm going to do that now. Right. And we got to move this over a little bit. There we go. So down here in our process, we're going to take a look and see if plasma volts I dot life is greater than 0. We process it, else we've got to like queue it up for well, we've got to queue it up for deletion. I think what we want to do so what we want to do is we don't want to remove the object from the list while we're working on it. Instead, we want to create like a queue of indexes. So we're going to have to do the same for asteroids, I think, once the asteroids can be destroyed. So I won't even do this. Okay, so plasma, or let's call this bolt delete queue. So if the life is greater than 0, we process it, else bolt delete queue push I. So every time we loop through this for loop, we add the index of any plasma bolt that is ready to be deleted to this queue. And actually, we should unshift it, and I'll explain why. Because we want to loop, we want to go backward through the list. Basically, we've got this, let's say we have 2 different plasma bolts that have run out their lifespan and we need to delete them. We have the indexes as they exist currently in the array. And if we go in order, then the first one we delete will shift all of the elements back 1 index. And then the next one that we were supposed to delete will have an index, a lower index. And we will end up skipping over it to the next element, or we'll have an error because we'll be looking for an element that is no longer there because the list is shorter. So the smarter thing to do, there are other ways to handle this, obviously, but I think the smarter thing to do is to go backwards. In this case, we're deleting from the back forwards. So what we're going to do is we're going to do I equals 0, I less than bolt queue length, which means we'll skip over this entire loop if there's nothing in the bolt delete queue. And then, in fact, we could even just say is alive, because there are, once the plasma bolt contacts an asteroid, it will also need to be deleted. So I think let's add, before we go any further, I'm going to add this dot is alive equals true. And when the life counts down, if life, let's see, if this dot is alive, then we process stuff. Here we go, like this. And if life is less than or equals 0, then this dot is alive equals false. Nice and easy. If for any reason the is alive flag is false on our plasma bolt, then we queue it up for deletion way down here in our process. Sorry, somebody's playing music downstairs. I hope it doesn't come through the mic. All right, so now we've got our queue, our reverse queue of plasma bolt indexes ready to be deleted. Their life has run out for one reason or another. And we can loop through that queue in order because we're going backwards through the actual plasma bolts. Oh, excuse me. Getting a dry throat with all this talking. So, this from here it's pretty easy. We can splice, I think. I want to say we can splice from the index here, and we do like a 0. I'm actually going to double check. This is a really common thing to do. Mdn Array Splice. Mozilla Development Network is a really great way to check up on JavaScript stuff and remind my... For me, I use it all the time because I forget all these things. I want to say that splice... Oh no, splice inserts or replaces stuff. I think I want slice. No, the original array would not be modified. So I do want splice. That's right. So we want start, delete, count. So start is going to be our index, and then we're going to say 1. We're always going to say 1 for the delete count because we only want to delete one item. Just splice also allows you to add in as many items as you want at the point that you've deleted, or that you haven't deleted, depending. So back in here, we want splice, the bolt delete queue index, and 1. And that's it. That should solve our problem. So if we go back to the browser and the game, where I'm getting killed again, and it looks like there's snow going past, like a snowstorm or something, we run into an error. I don't know what error, though. Am I not calling the process function or something anymore? What happened? Oh, I'm not passing delta. Okay. Back to script. I forgot to pass delta into the new process function that I made. Silly. When you're making, it's a bad idea to make a change like that and not check it right away. That's my fault. Sorry. I'm moving a little too fast sometimes. Oops. I'm typing in the console instead of controlling the game. So now if we shoot, they should disappear after a little while. Yeah, there they go. They last quite a lot longer than I thought, but not too long. And they're all over the place. Look at that. Boop, 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 and then they go away. 3 seconds seems a little long now that I'm seeing it play out in real time, so I'm going to cut it in half. I'm going to knock it down to 1.5 seconds. Here it is. So I do want to do one last thing before I go, but I need to take a break for like 5 minutes. So I'm going to pull up my timer. Here we go. And I'll be right back. Okay, I'm back. So, not much going to be, I'm not going to cover much else in this stream except pretty big deal, which is actually breaking the asteroids with the plasma bolt we've created. So for one thing, I'm going to make the asteroids move so fast. I'm going to slow it down because it is definitely too quick. Cut it down to 64. Let's see what that looks like. That's a little more manageable. It still doesn't look very smooth to me. It probably looks even less smooth on the stream, honestly. Just the nature of my internet connection, I'm afraid. But what we gotta do now is the asteroid should have... Oh yeah, I haven't been doing return this on my class declarations, which is not strictly necessary. I think it's just kind of an old requirement that tends to show up a lot, and maybe it's good practice, I'm not sure. But suffice it to say, we want is alive on our asteroids. And right, if something happens to the asteroid where they are no longer alive, then we queue them for deletion, like with the plasma bolts. So, with the plasma bolts, I guess all we need to do is that point collision again. And the point, the plasma bolt's position is actually the tip of the bolt, the front end of it. So it's not totally accurate to the shape of the object, but we can potentially deal with that later. So what do we want to do? In our process, we need to have an asteroid delete queue as well. Delete queue. What? The music isn't all that loud, but I worry that it's somehow coming through anyway. It's hard to tell. Hopefully it's quiet enough and like noise cancellation is cutting it out or something. Don't know. I'm not going to complain too much. If you're having a good time, I don't want to ruin your fun. It is a Sunday after all. I'm just stuck inside by circumstance. So let's do the same thing. Oops. Unshift the current index. I guess the only problem with this method is that if the asteroid bolt or both are destroyed on this frame, they won't get removed from the queue until the next frame. The bolts won't render, but I guess the asteroids still will, and they still are being processed. So, don't know. We'll have to just wait and see. So our handle collisions method, though, where did I put that? I put that in like a weird place. Let's put it down here above process, so it's a little closer. Everything's a little closer together, so we can see it. So if ship is alive in asteroids, point is inside ship. Great. We do want to check our plasma bolts too. So, yeah, let's say else if, yeah, because if the ship, we should kill the asteroid as well. That's something. Before we go any further, let's kill the asteroid and make sure that our asteroid queue, we can test that our asteroid queue deletion is working as well. And I'll actually add a kill method to the asteroid. Where is it? Here it is. Right? I can just copy all this stuff for time's sake again. Oops. This is alive equals false. And, you know, we can do some other fun stuff later, like actually animate what it looks like when the asteroid or what have you is destroyed. So, let's see. I'm going to add a kill method to the plasma bolt as well, even though I didn't before. Just for consistency's sake. And again, because we want, we might want to have the plasma bolt do some kind of explosion when it gets destroyed. So back down here and handle collisions. Ships kill, asteroids kill, great. We want to do, we can duplicate this, I think, safely. We want asteroid delete Q. There we go. Asteroids splice. There should only be one asteroid in the queue ever, because we only have one in the scene. That I will fix in the next part. It'll probably be another stream. Now that's odd. Something's happened, and now the asteroid is gone. Why is that? Asteroids equals. Let's take a look. Let's take a look in the code. I'm gonna put a breakpoint. Actually, I'm gonna put a breakpoint after the first render and see what happens. Okay. So let's see. Asteroids is already empty. That's interesting. Why is that? Okay, let's go back to the code. I must have slipped up somewhere. Asteroids kill if point is inside. That is so weird. Okay, let's go up the list here. If ship is alive and asteroids at point inside. You know, I should probably also do this. Well, no, you know what? It doesn't matter to check. Right now, it won't matter if I check whether the asteroid is alive first, because it'll be removed from the queue relatively quickly. Question is... Oh, I didn't set is alive to anything. I didn't initialize it true. That is why. Okay, mystery solved. Now we can move on with our lives. So let's move through and get destroyed, and we should break the asteroid with it, with ourselves, if we can actually hit it. I thought that making the asteroid slower would make this process easier. Hang on. But it's just pointed out how difficult, it's just highlighted how difficult it is to fly the ship the way I've designed it. Okay. There we go. Just nice and slow. Bam. And they're gone. The player ship returns and everything is right as rain. Now, we can go back in here and we can check for collision on our bolts as well as the ship. So here it is. Else. So if we didn't crash into the ship with the given asteroid, we have to check the bolts. I'm thinking that there are going to be more bolts in the scene than asteroids. I'll worry about that later. There we go. What occurs to me here is that if there are more plasma bolts in the scene than asteroids, I don't know whether it's quicker to loop through all the plasma bolts, potentially for each asteroid, or if there's some other way to do it. Because I guess the only other alternative is we loop through each plasma bolt, checking to see if it collides with each asteroid every frame, and I don't think that's any different. Yeah, I don't know. I think we just have to do it this way. I'm not clever enough of it or well read enough to recognize this problem and know a solution for it. This game is so simple, luckily, that it's not going to be a serious issue. But this is the sort of thing that can creep up on you where you're like checking, you're doing nesting for loops in each other so much that you end up with a lot of problems. I am going to say else if asteroids I is alive, because, oh no, you know what? Not even that. We're just going to do this because I pointed out before, and I'm going to repeat it again. We don't actually remove anything from the queue until the next frame after it has been killed. So I want to skip over, I only want to do all this stuff if this asteroid is still alive. So now that we've checked that, we can go ahead and do basically this same check again. We can say if plasma bolts I dot is alive, same issue, and asteroid's point is inside, and we're going to say, oops, plasma bolts I dot x and y. Add another parenthesis because we need it. Then we can do, I'm actually going to just select more than I need and then cut away the rest. Boop. And we can call kill on both of them. And this should have the same effect as crashing into the crashing the ship into the asteroid. So now that we've done that, let's refresh. Now I'll turn and fire. And I missed, but I hit it. It looped around and hit it, and the asteroid is gone. There you have it. Boy, 2.5 hours later, and I've gotten most of the way done. There's a bunch of more stuff that I want to do to actually consider this a complete tutorial for what I'm trying to make here. But for now, that should be pretty good start. Remember to check out the first video if you haven't seen it. By the time this goes up on my streaming archive, it should, I should have a, what's it called? Code pen. I'll have this up on my code pen so that you can see the code for yourself. And I'll update it on whenever I get around to doing the next tutorial. So tomorrow, since tomorrow's a holiday, Indigenous Peoples Day is tomorrow. I'm not going to be streaming, but I'll stream on Tuesday instead. So look for more the continued adventure in Off, the classic RPG Maker game. Yeah, so at some point I'm probably going to edit all of this stuff together into a slightly shorter video where I cut out all of the rambling and mistakes and stuff. But I hope you'll join me next time, and until then, I'll see you.